In this video, I'll write a program which converts this video into this. So as you can see, in the output video, the face of the person speaking is blurred. So this is a technique I'm going to use. I'm going to blur the area around the face so that it's not visible. You can also use other techniques such as writing a rectangle which is filled in, but this is a more standard practice. So let me show you how I can do this using, of course, OpenCV. So import CV2 and load the video. You can find the video attached in the lecture resources. So the input video, which is smile.mp4, and this is the output video. So I'm going to delete the output video and recreate it using OpenCV. You also have this faces.xml, which is the cascade file which contains the blueprint how a face looks like in XML code. So the program needs to have that file in order to recognize faces in a video. So video is equal to cv2.video capture. What I'm doing is I'm referring to smile.mp4 and create a video object in Python, and then create two variables, success and frame is equal to video read. So what I'm doing here is I'm reading the first frame of the video just to check if the video is read correctly. So success will get true or false as a value, and frame will get the first frame as a value. So if the frame is read successfully, success will be equal to true, otherwise it will be equal to false. Then we have face cascade, a variable which points to cv2.cascade classifier, and that points to faces.xml, the path of the XML file. So we have the video, we have the first frame, we have the face cascade object, and then we create an output which is empty for now, so that is equal to video writer. Let's name this file output smile.mp4 or blurred smile if you preferred, or blurred face. So that is the output video. Now this requires also another argument here, that is cv2.videowriter underscore 4cc, which is a class by itself. It expects now this argument, which is the codecs of the video you want to create. Div x, this is what works. I've tried this, and 30 frames, it's another argument. So we've got the path to the output file, the codecs of the video as a second argument, the frames per second of the output video, and lastly the dimensions of the output video. Now this should be in a form of a tuple, which could be something like a 300, 400, but you can just declare these numbers like that. You want to have the same width and height as the original video, so that you don't end up with a distorted video. Therefore, we need to get the dimensions of the original video. So what I'm going to do is, after we create the video object, after we get the first frame, we get the dimensions of that first frame. Height is equal to frame.shape, and we get the first item of that tuple, so that creates a tuple with the height and the width, and the width is equal to frame.shape 1. So then we can specify here the width, which comes first, and the height. So those are the dimensions of the output video. Then we're ready to build the while loop. While success, for example, which is equal to true. So if success is true, then we build the while loop and write frames in this output video object. So while success, we detect the faces from using face cascade. So that object, which has a detect multi-scale class, and this gets the frame as input. So we're working on the first frame for now. We detect faces in the first frame, and these are the coefficients, and so I've covered those. 1.1 and 4 is a good set of numbers. So if you change these, you can make the algorithm more sensitive or less sensitive. So if you make it oversensitive, it means you will detect false positives, so false faces, objects which are not faces but are classified as faces from this algorithm. So that will give us a list of faces, because we might have more than one faces in the frame, but then we can iterate over the faces for x, y. So each face has an x and y and width and height. So these are the dimensions of the rectangle around the detected face. So we say for that tuple in faces, and then we modify the current frame. So the current frame, but we only modify a particular slice of the frame. And that is the slice, the portion where the face is. So with this coordinates y, so from y until y plus h. So that means where the rectangle of the face starts and until somewhere in here. So we get that portion, and then we get the other portion as well. So we go again from x to x plus width. So that will give us basically that and that. So it will give us the entire rectangle where the face is. So the entire frame is something like this, right? And the face has these coordinates. So now what we do to this portion of the frame here is we apply a cv2.blur method. And this goes like this. So frame again, y plus h, and x until x plus width. And then we also provide the intensity of the blurriness. So 50-50 is a good number. You can go less than that if you want the face to be more visible, and you can increase these if you want the blurred effect to be more intense. And that's it. So now we have modified that portion of the frame by blurring it out, and then we exit the loop and we say output.write frame. So we write that current frame, that modified frame, into the output video. Then what we do is, so far we worked on the very first frame of the video. Then we want to get the other frames. So we say again success and frame is equal to video.read. So that will read the next frame of the video. And that's it. So the while loop will be repeating itself, and we exit the loop and we say output.release to release the video and make it able for writing it on disk. So I'm going to execute this now. Now, if you get this error, there is a mismatch between the formats, the video formats. That means you want to change the output from MP4 to .avi and run again. You can see that blur, smile, .mp4 is created, but the script has not ended execution yet, so we want to wait until this file is written. And of course, for the next time, you can improve the experience, the execution, the program execution experience by writing here a variable count is equal to 0, and then here you say count is increased by 1, and then you print the count so that you can see some output here. So you see the while loop being executed. You see these numbers. Actually, I can stop this and run it again, and so that we can see some output in here. So now we see the count, which basically represents each frame. So every frame now is being processed. We are in the 8th frame, 9th, 10th, and so on. There will be 90 frames in total because the video is 3 seconds long. So there are 30 frames per second. 30 times 3, it's 90. Yeah, so the execution has finished. I can download the blurredsmile.avi file. And here it is. So you can only open this, at least in my case, I can only open it with the VLC program, VLC media player. So the other ones might not work. And yeah, that's the output, and that's the final code. Thanks for following this, and I'll talk to you in the next videos. See you.